So hello guys, today we'll be discussing about some question answers of the very beautiful topic, that is real analysis. Okay, so in these questions you can really see what is the beauty of real analysis and how you should think about it and what should be your approach to solve a question. Okay, so now let's talk about the first question, that is let A belongs to R. So here it says A belongs to R and X is a real number. That means A and X both are real numbers, and X belongs to V epsilon of A for every epsilon greater than 0. Then you have to prove that X equal to A. Okay, so while you are solving a question of real analysis, what should be your approach is, like how to think about a question is, first of all you have to think what is given to me. Okay, second you have to think what should I get at last. At the end, what should I get to prove this one? And third of all, last but not the least, you have to think what should be my approach. What should be my approach to get the last step or the last point? Okay. Generally, there are few ways to solve questions, like contradiction method and various methods are there. Most common one is contradiction one. Okay, so in any of the cases you have to look for the given, then what should do you get at the last, and what should be your approach. So first of all I will write here what is given to me. Here given answer given is X comma A belongs to real number sets and X belongs where? Now V epsilon A. Now what is V epsilon A? Here you write V epsilon of A is the epsilon neighborhood of A. If you take a here I am taking a number line. Okay, let's mark a point A over here and I give a neighborhood, that is epsilon neighborhood. This is the distance of epsilon. Okay, so X will lie in this region, in this particular region. X will lie somewhere, maybe here, maybe here, maybe here, anywhere, or anywhere, we don't know. Okay, for every epsilon greater than 0. What is epsilon? Epsilon is a positive number, that is epsilon greater than 0. Okay, so X might be here or here, anywhere maybe. Now we will understand what the question says. Question says for every epsilon greater than 0 in A, in the neighborhood of A, we can choose a X. So we have to choose an X. Okay, let's take a number line like this and we choose a point over here A. This is the neighborhood, epsilon neighborhood. Then we can choose the point X over here. Okay, so epsilon is arbitrary. If I am taking this neighborhood instead of this long one, wait a minute, instead of this long one, if I am taking this small neighborhood. Now x will lie inside this neighborhood, not this one. Okay, so now x belongs here. I think I should make it a little bit larger. Now again I will reduce the size of my epsilon. Again, what will I do? I will reduce my size of epsilon this much. So what should be x? X should be here or here anywhere. Similarly, if I take it closer, now see, I'll take very less, however small I can take. Here I can take, so x will be here. Again, if I reduce like this, x will be here. Again I reduce, x will be here. Similarly, what you can see, it can approach to 0. It is approaching 0 over here. Okay, it is approaching to 0. Sorry, it's approaching to a. In that way, what you have to show, see, I will erase this one. This is our point A. So what it says, focus on this the word for every epsilon. For every epsilon, there must be x inside the neighborhood of A. I think it's getting a little bit complicated, but try to understand, okay, what it says. Now A is here, so epsilon, so we can show that x will be at A point. How? From the statement, if you can see that epsilon is a positive number. Epsilon is a positive number, isn't it? Epsilon is a positive number, and x belongs to the epsilon neighborhood of A. Okay, so we can write A minus x mod will be less than epsilon, isn't it? See, x is somewhere here, A is here, so x minus A will be this distance, and this distance is lesser than this distance, that is our epsilon. Simply we can write it, or in other way we can write x minus A is less than epsilon. Done. So if we can write x minus A is less than epsilon for all epsilon greater than 0, that is our condition. X for every epsilon greater than 0, x minus A will be less than epsilon. So what can be there? We have two conditions. The modulus of a number cannot be 0, so it may be 0 or positive, but we can take any epsilon, as much as smaller we can take. So definitely we have to take x minus A is equal to 0. How? See, this number is less than every positive real number. This number is less than every positive real number. That means what? It can be negative, so it must be 0. If a number x is less than every positive real number and mod x, if mod x is less than every positive real number, then mod x must be equal to 0. Okay, keep it in mind, and you can see it's a general thing. Okay, so what will happen? X minus A will be equal to 0. Done. So this is the thing we need to prove at last. X minus a is equal to 0. So what you got here? You knew what is given. You got what should I get at the last? This is the thing we should get at the last. Now what should be our approach? What is our approach to get this line? Okay, so this was the basic, or you can say this is our approach to think about a question. Now we'll come to the points, like how should we write in examination. If you want, you can take a screenshot of this one. Okay, 3, 2, 1. Now we will write it as according to the procedure. Okay, so given here I will write 1 minute, let me just given a belongs to R and X belongs to the epsilon neighborhood of A, that is V epsilon A, for all epsilon greater than 0. This is the most important thing. Okay, so we can write X belongs to R. We know X is a real number. We know X belongs to R. So for X, what we can write? A minus epsilon less than X less than A plus epsilon, isn't it? Or you can write X minus A modulus will be less than epsilon. This we have discussed earlier. While explaining, I told you this, how it was there. So, and epsilon is greater than 0. So as epsilon is greater than 0 and x minus a less than epsilon, this we have discussed earlier while I was explaining about this, how to think. Okay, so what we can write over here, that we know epsilon is greater than 0, so 0 less than x minus a, 1 minute, x minus a modulus less than epsilon. It can be equal to also for all epsilon greater than 0. Remember, while discussing I told this x minus a is less than every positive real number, less than every positive real number, that is epsilon. Okay, so what we can write, x minus a, 1 minute, x minus a is equal to 0. That implies a is equal to x or x equal to a. Done. This is only 2 more questions. The main thing you need to think how we can solve this. Okay, so that's all about this question. Thank you.
रुक जाना नहीं तू कहीं हार के